In this lesson, we're going to look at expressions that imply we should divide, but honestly, you will not have any sense that any division is going on. And here's what I mean. If you had the square root of 3 divided by the square root of 2, you actually will not do division, but it is considered in math totally inappropriate to ever have a radical in the denominator. You must have a rational number in the denominator to divide by a rational number. This comes from a long time ago when people didn't have calculators and it was easier to do long division by a simple number like 2 or 5 rather than the decimal approximation for a radical that might have been something like 1.41796. So we wanted our denominators to be rational. To turn that denominator into a rational number, the technique we're going to use is to multiply it by the number 1, because 1 is the identity for multiplication. But that 1 is going to take the form of square root of 2 over square root of 2 for this problem. The reason we're doing that, and we've discussed it in an earlier video, the square root of 2 times the square root of 2, yes, it is the square root of 4, but the square root of 4 is rational 2. That's where it gets the name rationalizing a denominator. Square root of 3 times the square root of 2 is the square root of 6. That's a rational number. That's inside the radical. No, you cannot divide it out. So leave it. You have made the denominator into a rational number. So whatever is under the radical, that's what you're going to choose to create your number 1 by. All right, number 1 in the examples, it says to rationalize the denominator. In order to do that, I focus on the denominator. If you could simplify this, you would do that first, but you can't. So you multiply by the square root of 3 over the square root of 3. That gives you the square root of 30 over square root of 3 times square root of 3 is 3. I know it's the square root of 9, but the square root of 9 is 3. Can you simplify this? No. Is there a rational number to reduce with the 3? No. So we're done. Let's look at the next one. All right. This is the same as the square root of 1 over the square root of 41. The square root of 1 is 1. I always simplify any radical I can. Now the square root of 41, you can think about it for a little bit, but I think you'll find that there is not any perfect square that you can factor out of that. So let's multiply by the square root of 41 over the square root of 41. That gives us the square root of 41 over plain old 41. Nothing I can do with it. We're done. Number 3. This is the same as the square root of 49 over the square root of x. The square root of 49 is rational 7, and I don't know what the square root of x is. I'm going to rationalize the denominator. I'll use the square root of x over the square root of x to do that. That gives me 7 times the square root of x over square root of x times square root of x is x. Remember, you cannot do any reducing because this x is under the radical and this one is not. We're done. Number 4. Always check to see if you can simplify any of the radicals, if anything's a perfect square, and it's not. So I will rationalize this. What do I focus on? I focus on the denominator. I'm rationalizing the denominator. So I'll multiply by the square root of 3 over the square root of 3. That gives me 5 times the square root of 21 over 3. If these two rational numbers could be reduced, if they had a common factor, I would do so, but they don't. Also, if the radical that you create up here could be simplified, you would do so. You're always looking to see, can you simplify, can you reduce? But the answer is no. And that looks like our 4 problems for this. You're rationalizing a denominator that has a single radical in the bottom. So give that homework a try.